Hi, so welcome back. Like I said previously, I would be doing a video on an overview of the mathematics section of this channel. This and now, if I happen to leave anything out in this video, I'll just make a second episode. Doesn't have to be a huge issue. A really huge issue in the sense that it leads to some bad outcome and stuff. Alleviates some stress when you focus more on outcomes. Let's get to it. So, now, for my background in mathematics, I have a background in mathematics. I got my associates in theoretical math from Georgia Military College. I can grab my diploma here, just a moment. Okay, yes, I have it here. Ta-da, see? It's there. Got that, I completed that, and also have my bachelor's in math. Unfortunately, I dropped the frame, which thankfully is only $11, so that's easy to replace. Damn, it's a shame what happened to this glass. So, yes, I'll be putting these back now. So, now with that, there's some variations to that degree. It was through schools that are purposed for the military. They weren't inside the military like base schools, but there were schools tailored and specified for military personnel. Georgia Military College is more focused on the Army. American Military University is part of American Public University System. American Military University is more focused, I think, it pretty much takes in everybody. And I think there were I know I saw some Navy too at Georgia Military College as well. It's not that it was exclusive to the other branches, it's just that it tended to be that it was mostly the Army that went there. And there was a large amount of civilians too. I think like half of that school was civilians or something. So, yeah. When I completed my at the end of my program, as part of my completion, I had to finish my exit exams. I scored very well in those exams, certifying that I could carry my skills out into the real world and that I remembered my degree and I knew what I was talking about. My degree concentrated on operations research, and I specialized in game theory. Operations research, I studied a wide variety of other things, including things outside of mathematics as well. Some being mechanics, some being philosophy, and IT, a bunch of stuff. I have a background in IT too, so but that's another topic. Our IT video series is another series. But now to the rest of the brass tacks, let's talk about the topics we'll be talking on this channel. Seeing as I have to take my GRE math and my GRE, I have, as well as GRE verbal and stuff, I have to focus on GRE topics. And but I also want to make sure that you have more than adequate, all of the literacy in mathematics, so you can do as well as possible in your courses, be they in college, grad school, whatever. So yeah. Now, we have to because we're learning math, we have to start out with the right premise and stuff. There's a lot of half truths and just BS about what mathematics is. Now, the question is, what is mathematics? Well, like in chess, Paul Murphy, arguably one of the greatest chess geniuses of all time, arguably the most naturally talented. He said that tactics flow from a superior position. This video series is going to teach you how to develop mathematical language into the advantageous positions where you can use tactics that can get full points in any test, assignment, etc. This course will make you a mathematical expert. So So we're not going too far from what I said initially. What is mathematics? Well, math works a lot like programming code and stuff. Math has the same rhythm as chess. A chess player, you remember. Okay, I'm reading a little bit too much off of what I wrote here. Let's just restart again. What is mathematics? And math works a lot like programming code. It has the same rhythm as chess. Math is an art form. It's a tree that splits into different disciplines. Math is analytic in its nature, meaning that it has just the scant important details of things and stuff, because the purpose it tries to serve is it takes things that have all these unrelated details, unrelated factors, and it filters out all that unrelated stuff down to the stuff that's important. And it takes things that are too complicated for a person or even some cyber systems to process, and it brings it down into thinkable format by just focusing on the things that are important, on the capital variables and stuff. Why do we add a plus b, and focus on the result of c or whatever, for example? Well, it's because c is what we're tracking, and a and b influences c. For one example of many of cases of just this mathematical filtering process. Math is a divine benign. It's working constantly regardless of context because it gets its power from reference. Math is a canonically referentially backed language, meaning that the meanings of the terms are well defined. They come from writings and from research from people that wrote the language and stuff, and it's backed by reference. It's canonical. It does not break down into math does not break down in a black hole, a wormhole, or any time or place. It works regardless of any time or place. But you cannot, mathematical expressions, they tend to be restrained on which time and place they're talking about and which context they're talking about and stuff. So you can't just figuratively stretch an equation over multiple times and places, that in the sense that it's being unnaturally extended. Okay. Ill-defined or overly loosely defined terms don't exist in the true mathematical system. It is like reason, information, intuitive truth, good, or the other divine benign things that seem to sort of supersede reality and trump even things like black hole gravity waves that distort the massive energy around them. Math retains its form when context changes, and that means it retains its function. Math is arguably omnipotent. It can analyze at both the macroscopic, above reality, and below. It can analyze the subnanoscopic or the subquantum, the quantum, the macroscopic, the universe engine level, and beyond of that. Math is something that can work beyond reality. It is because it is a kind of information. It is above the power of reality, and it is beyond just what we can do with it for everyday things. It is as powerful as magic, and because it grants us the ability to precisely, intentfully address in a sea of information and matter that is arguably infinitely complex. So whoever masters it truly masters it and gains a superpower. Math is connected any combination of relationally or conceptually in a way that human language is not. It exists conceptually as analytical classes with figures made of just the minimum necessary details, and only a range of terms to describe the meaning are permitted for this reason. Math is an abstract technology for taking account of the important details. So reiterating what I said before, because I wrote this like a few days ago, so I don't, math is an abstract technology for taking account of the important details of a real or conceptual system. It can bring otherwise oversized or complex systems down to a, just making sure I'm recording, a manageable level of detail because of how the manageable level of detail because of how the numbers, letters, and symbols spatially and relationally line up what they represent. So what topics are we going to talk about? We're going to talk about analysis. We're going to talk about interpretation. We're going to talk about expression, human language for mathematics and notation. So that's 3 topics so far. because expression, human language, mathematics, and notation are grouped. We're going to talk about the fourth topic of fields of syntax. The fifth is the science of quantity, quantity science, not quantitative science. That's arguably what we're talking about already. There's no point in using it redundantly. We're saying quantity science, such as infinity, discrete continuous values, and finitehood, different kinds of blah, blah, blah. Some personal notes for myself here. Number 6, positional evaluation and principles, including continuations and positional improvement. Again, tactics flow from a superior position. How do you get the tactics to write the next line in mathematics and stuff? You need a superior position. And I'm gonna in lessons coming up, we're going to be talking about how to attain that superior position, because often we are given nothing. Unfortunately, we have to make something from it, and and we have to produce quality work. So number 7, problem-solving theory, mathematical, and number 8, mathematical formatting. Number 9, unified rules in math and fields. Number 10, science, art, application, and philosophy of equations. Equations are very central, not necessarily more central than others, but they're very central. The science art, number 11, the science, art, application, and philosophy of geometry. The science, art, application, philosophy of logic. SAAPE. 13 is problem-solving theory. 14 is proof theory. 15, modeling theory. Number 16, computer programs, applied math for programs and computational methods. Now you're thinking, wait, why are computer programs in here? Well, the first computer programs were written by mathematicians. They were the result of what are called mathematical words, meaning letters that are written next to each other and stuff in mathematics. So not necessarily variables. They have a different kind of class assigned to them, or a different collection of strings that are arranged in lines, and they can create functions and stuff. They have meaning, they have input and output capacity. Number 17, math. We're going to be discussing math knowledge and facts for the academic purposes, work purposes. Math knowledge and facts concerning arithmetic, algebra and algebraics, calculus, geometry, proofs and logic, statistics, linear algebra, the essentials of the advanced math fields such as topology, mathematical philosophy with introduction to philosophy, because you need to know some philosophy to understand mathematical philosophy and stuff. You just have to. You just have to. Because I would like you to understand this in completion. And of course, it advances my own learning too, because again, GRE and all this other stuff. 3, philosophy of physics with introduction to philosophy. And you're probably wondering, why is physics being mentioned? Well, physics is a type of applied mathematics. Number 4 is multivariate calculus. Number 5, differential geometry. Number 9, applied mathematics of physics, engineering, the arts, programming, and chemistry. So yeah, we won't be covering applied mathematics of every little thing, but we will. I mean, we could throw finance in there. Yeah, I guess. Yeah. Number 10, applied math. 11, GRE, the GRE math topics, which are as of what I could find today in August 24th, 2025, abstract algebra, elementary and linear algebra, number theory, differential integral calculus, theory and applications of geometric calculus, for real analysis, specifically sequences and series and numbers and functions, continuity, differentiability, integrability, discrete math, logic, set theory, combinatorics, graph theory, and algorithms. So all of that is under real analysis after I mentioned geometric calculus. So everything that I mentioned after geometric calculus up until the end of algorithms is under real analysis. But that is not all of the real analysis. Thank God, because I really don't want to spend too much time with it. It's called 5, elementary topology of the real numbers and the real numbers to the nth power, or real numbers with superscript n. I'm pretty sure that's not exponential. Number 6, numerical analysis. Number 7, complex variables. Number 8, geometry, number 9 probability, number 10 statistics. So everything from 1 to 10 that I just mentioned here is under the GRE math topics. So this gives you an overview of what this course series is about. I'm hoping that it will leave you with exactly the understanding that you need, so you don't need to flip through a bunch of pages and stuff and waste your time doing stuff that's unrelated to learning, or like the process of like actually processing the information in your brain. So I'm trying to make this more streamlined and efficient, more straight up, and without omitting anything important. So yeah, what time am I at right now? I'm at, I can't see how long I've been recording here. I know there's a timer here. So, oh, here we go. 15 minutes. Not too bad. Almost 16 minutes. So yeah, I can cut it short here. And hopefully I'll remember to wash my dishes before I record a video, too. It's a little bit bothering me. I mean, that food was delicious, but damn, I really don't want to see it over my shoulder. So yeah. Anything else? No, I guess not.